In this video, let's look at arc length and area of a sector. We may get into some linear and angular velocities on this video. That may also be on a separate video. Let's jump right to the arc length and area of a sector. If you take a circle and cut a portion out of it, again, going back to like the pie and the cake reference, the cuts that you make are considered the radius. The crust or the outer arc is called the arc length, and the angle that's formed inside, your central angle, is theta. Now the relationship that these have with one another is that arc length is equal to radius times your central angle, but you got to be careful that theta is in radians. If they're in degrees, you will have to convert them to radians before you use them in that equation. If you were to actually cut out and remove that piece of pie or piece of cake, the part that you remove or the slice you take from it is called a sector. The area of that sector can be found using 1/2 times the radius squared times your central angle. And that angle will also have to be in radians. If it's given in degrees, just use the conversions from our first video and convert your angle from degrees to radians. Okay, so let's look at a circle with a 7-inch radius and an 11-inch arc. Can we find theta? Since arc length is radius times theta, if you divide both sides by radius, you get S over R equals theta. So for this particular diagram, 11 over 7 radians. What would be the area of that sector? For example, what's the area of that piece? Well, area is 1/2 times the radius squared times the central angle. Well, we just found the central angle in the step above, so we can sub in 11/7. This is going to be 1/2 times 49 times 11 over 7. All right, let's multiply 49 times 11. I get 539. The denominator is 2 and 7, that's 14. So if we take 539 divided by 14, that gives us 38.5. Our measurements are in inches, so the area is 38.5 square inches. Let's suppose that we have a water sprinkler set up where our water sprinkler rotates, and it's mounted here. And let's just suppose that with the water turned on wide open, that it waters this sector of grass. Suppose the water sprinkler can shoot a stream of water 30 feet, and we've got the pivot set to where almost a right angle is watered. Let's call it 80 degrees. So it's going to water all the grass in this sector. Let's see if we can find the area. Now it'll be in square feet of grass that gets watered. So let's see if we can't figure that out. The first thing is, if your central angle is not in degrees, if it's in degrees, you have to convert it to radians. This is a good review because 80 degrees times pi over 180 degrees . 80 over 180 reduces to 8 over 18, which further reduces to 4 over 9. So this angle in radians and reduced is 4 pi over 9 radians. And that's the format we need it in. Now we can move forward and calculate the area. Area is equal to 1/2 times our radius squared. Our radius was 30 feet. And our central angle, 80 degrees, that's equivalent to 4 pi over 9 radians. $30 squared is 900. Okay, so let's multiply. Across the top, we have 900 times 4 times pi. That's 3,600 pi. The denominator, 2 times 9, that's 18. And then we're just going to approximate this to 2 decimal places. 3,600 times 3.14 divided by 18 gives us, wow, that come out nice, 628 square feet.